So this is the second video in the series on using census data or accessing it and using it in real-world contexts. And so the last video we visited data.census.gov and tiger shape files. We pulled the I, the information. We pulled the G, the geography. And now I want to get it, see what it looks like in ARC and sort of close out that loop. So first thing, just so that I'm using these videos to remind, and build habits. Anytime you open a new map, set up and make your data linkage. Again, I don't know what your computer is going to look like, right? I'm going to go desktop. Oh, not what I wanted. There we go. Just pick desktop, open. Ugh, it's driving me crazy. Stop this. My computer. Just desktop. That's it. Not open. What's going on here? Let me try it over here. Add a folder connection. There we go. This PC, desktop. Okay. All right. So I've got my desktop, and one thing I want you guys to do, I provided a piece of data for this, called October 1st census data. This is where I just pulled out Philadelphia from the data we're going to analyze in a second. Might be something slow on my computer. I might need to restart if it keeps being slow. But just where I sort of pulled out what was in Philadelphia and projected it in the coordinate system we're familiar with. This is what we're going to join in a second. So duplicate this if you don't mind. But I do want you to insert a new map for a quick second, just so we're kind of seeing and visualizing what the data we downloaded looked like, the TL file. I dragged that to my desktop, and then I clicked right-click on desktop and refresh so I could see it. And I'll open it and bring it in, and it's exactly what we pulled, right, the entirety of Pennsylvania. Now, as you can see, this looks a little different. It's a little flatter. It's because it doesn't have a projected coordinate system. And you absolutely could work with this data right here, but just so you get a sense of what I did, I came in here to the attribute table. And, one of the neat things is like the code here, the GeoID, that's the sort of census tracts ID, right? That's the tracts ID. The county is the county in Pennsylvania, and the state 42 is Pennsylvania. So 42 plus county plus tract is your ID. I just took sort of the Philadelphia, which is the 101. I selected everything that was 101 and exported it and projected it. So we're not going to work with this one, unless you want to. You are more than welcome to do exactly what I'm going to show you with this data set. I just wanted to give you sort of a sense of kind of what we were ultimately working with. So if you open up the, drag in the October 1st sort of Philly projected data, we always check our attribute tables to see what's available to us. It'll look similar to what we just looked at, except it's all going to be 101 because it's Philly. And there's no information, really. I mean, the best thing we have here is this GeoID. Because the moment you bring that in from the census, or really the moment you bring any kind of information in that is disconnected from a geography, your mind should immediately think join. I need to find an attribute, a field, an identity that I can one-to-one uniquely connect back to the geography. And in this case, it's going to be GeoID. So now let's drag in sort of the CSV. So let's find wherever we saved it to. I think it was called demographic data, so I drag it in. Now, if you remember from a previous class, dealer's choice here. Sometimes I like to right-click data export, just because ArcMap is a little bit better at working with DBF tables. But we'll be fine working with sort of a CSV right here, just for the purposes of this lesson. Let's open it just to see what we have at our disposal. Right, okay, each row is still a census tract, and we have our data, but something's a little different, right? This is what your mind should be noticing. Okay, that kind of looks like the code in Philly projected, but it's got something in the beginning, right? This just goes right into the 42 versus this has this sort of like 1, 4, 5 zeros in sort of US. And so I should be able to work with this because there's a pattern, right? It's the GeoID code. It just has this uniform thing added. And I purposely picked these two sort of data sets that are fairly kind of compatible, but I picked the redistricting excuse me, data on the 2020 census tract, so we'd see this sort of slight misalignment. You know, oftentimes when you pull data from Tiger and maybe like the ACS or sort of the perfectly aligned vintage, the GeoIDs will look the same. Maybe one will be text and one will be integer. It's a little bit easier to do. But I wanted this slight misalignment to show you that if this happens to you with the census or anything, you're learning techniques in previous classes to deal with this. And we could do it in two ways, right? We could get fancy with a Python, right, in Field Calculator for those who dove a little deeper than what we did in Field Calculator last week. Use the split function and split this at the letter US and take everything to the right of it. A bit more complex. Maybe what we'll do here instead is we'll create a new field and we'll take the value that's in GeoID and we'll just concatenate at the beginning that sort of 14, 5 zeros, and US. You know, really, this is effectively what's at the start, right? 1, 4, 5 zeros, US, and then the field with the GeoID. And so we can do this by applying lessons from previous weeks. We can add a field. We'll make it new ID, right, to remind us that it's a new ID that we're going to join. Right? So we'll come in, we'll make it a text. 255 is the length. We'll come up here and save. Gonna be one of those nights, huh? ArcGIS, I suppose. So let it do its thing. Go take a walk, a 20-minute walk. I'll give this another couple minutes until I decide whether I'm going to put a stop in the video and sort of merge it. I'm clearly a lazy video maker, so we'll just hold on for a second here again. Okay, got it. So come on up here, we'll exit, and we're looking at our data now. We have our new field that's ID, right? The techniques we learned last week, right-click and calculate the field. And you're just going to emulate what I showed you there in sort of that Word document, right? The 1400 US plus the sort of field. And, you know, anytime you're doing Python, which is this language for Field Calculator, right? We learned last week that text needs to be in quotes. So we're making this a text field, right? 14, 1, 2, 3, 4, 5. Just make sure there's 5 so I don't put my foot in my mouth. 1, 2, 3, 4, 5. Capital U, capital S. 1, 2, 3, 4, 5. Capital U, capital S, end it. And then when you concatenate text, right, you use the plus sign in Python. That just means sort of smush those texts together. Say GeoID. You're literally taking the text 14, 5 zeros in the US, and you're putting it before whatever individual value is in GeoID. And bing, bada boom, you run it, and there you go. Right, now we have an ID that we can join. Now it aligns with our demographic data. And now what I can do is I can emulate that join we learned the other week. I can right-click my Philly projected and go to join and relates. Add a join. I'm joining to Philly projected. That's the shapefile. The field is the one we just made, that new ID. I'm joining from demographic data. That's the sort of CSV. It's going to be the GeoID, right? The GeoID was the field. That is the sort of 14, 5 zeros US in the ID. I'll hit OK. Bobbity bobbity boop. Right? We probably should have unclicked the keep all target records. Remember, we found that can trip it up if it finds sort of one join that didn't happen. Fortunately, we're OK. And we can open the attribute table to make sure things went swimmingly. I hope that they did, and I don't have to foot and mouth. But you scroll over, and there we go. All of a sudden, the data is here. We finally have a merger of G and I, right? You know, that sounds strange in a different way, but you get it. Geographic and information. GIS, mapping what's not quite there, right? We can come up and now look at some of the techniques we learned last week around dot density and such. I could come right up here into the symbology. pick dot density and pick a series of fields, like look at maybe the Hispanic and Latino population will show up in sort of a blue, and the white population will show up in, for some reason, also a blue. Let's see if I can change that color real quick. Maybe make that like an orange. There we go. Come and do a black population. Maybe we'll make in sort of a green, depending on what it defaults to. Make it easier to visualize. And suddenly I'm able to visualize something entirely new. I can see like the true reality of the way that Philadelphia's demographics are really structured. You know, Philly has several very integrated neighborhoods, so particularly up here in the northeast part of where we are in West Philly and segments of South Philly. But there are other sections of Philly that are incredibly segregated, right? The north part of Philadelphia has this very fascinating sort of demographic pattern where when you really go west of 9th and west of Broad, it's almost entirely black. And when you are east of Broad, between Broad and Aramingo, you are largely Latinx and Hispanic. And it is actually the second highest concentration of Puerto Ricans in the continental United States outside of the Bronx. And then you head sort of east Aramingo, and you're in sort of Port Richmond and Fishtown and those type of neighborhoods, which are largely sort of white. And we were able to do this in just a couple minutes, right? We can do this with any other piece of demographic data that we want, any census geography. This is how you grab it from those websites, maybe prepare it a bit in Excel so it's easier to work with, bring it in, and just using those techniques from the previous weeks, the field calculators, the adding the fields and the joins, we are able to create totally new visualizations and analytics.